welcome along. As I said, this is me. My contact details are there if you do want to connect either via GitHub or through LinkedIn. I'm a principal consultant with Mantle Group in the Microsoft domain, so I work primarily with Azure, but also do quite a bit alongside GitHub as well. So I've done some running of the GitHub user group, and I'm also recently an MVP in the DevOps and Azure IOC space. And so I've been involved with Azure since it arrived on the shores of Australia pretty much. I was working at a consultancy there and have managed to learn bits and pieces on the way past, and just happy to share my knowledge as we come through. So tonight we're going to talk about a new feature that's come out as part of Network Manager. Who's familiar with Network Manager in Azure? Yeah, we got one, a possibility in the background. So Network Manager itself is a reasonably new technology. The intent of it is to allow you to manage a hub and spoke landscape at scale. So it allows us to define routing tables, to define peerings between virtual networks, so that you can build out a big hub and spoke network without having to go and manually manage all of that on the way through. Great tool for doing what it does there, but one of the new pieces that's been added to it is IP Address Management. And this is one of those finally moments, because for so long I've been waiting and wanting Microsoft to provide us a decent IPAM solution. Did anyone use the open source IPAM that was deployable? Yeah, we've got a couple of nods there, and by the look of those nods, it was painful in terms of that. So it was better than nothing. It gave an opportunity to do IP management via code, to do it at scale. But now it's integrated into the Azure portal. And so that makes it really easy for us to use, because who likes managing IP addresses? I know we got one. There's always one. I know from my perspective, half the battle when we're doing Azure landing zones is getting from the network guys a list of IP addresses that we can use. And then once you've got that, how do you make sure that everybody's actually using the right IP addresses for the right things, so that you can do all your zonal firewall rules and things like that? And that's where IPAM makes a big difference for us. So what does IPAM do? Starting point, centralized IP address management. It's the point of an IP address management tool. So what we do is we load in there our pools, we can assign them out, and from those pools we can then look to use them. But they're all in one place, we know where to find them, and then when the APIs are working, they're going to be pulling from that same information. We then have a single point of view to see what's going on. It supports operations cross-tenant. So that's important for situations where you've got an organization that maybe their dev environment is actually in a different intratenant. And so we can, from one IPAM configuration, actually do that cross-tenant, and therefore be able to get a view across the full landscape. The pools are, as you would hope in an IPAM tool, hierarchical. So we define our parent scopes, and then we can drill down and divide them up as much as we need to in order to actually provide the granularity that we need when it comes to assigning IPs out. And with that, we've got full RBAC capability, so you can restrict who is able to deploy to which pools and so forth from there. And what it does is it gives us that automatic CIDR allocation. And that's the key thing, is not having to make somebody go and decide how big of an IP address do I need. And what we'll see when we hit the code is it's now simple as how many IP addresses do I need? And then IPAM goes and works out these are the subnets you're going to require in order to meet that definition of IP addresses. And then if you need to change that, you update that number, IPAM will go and change the spaces associated. And what that means is it makes it so much easier to create your VNets, because you don't have to think about it from there. So enough talking. Let's jump in and have a look at what this looks like. So if we jump out of there, so here we have, no, don't want that one. That's all right. I forget my keys. So that's here. I've created here a network manager from there. And this is as I said, the foundation of what we use. You can either create a new one for IPAM, or if you're using Network Manager for controlling access and everything, just bolt it on from there. One thing I wanted to mention in terms of pricing is IPAM, you pay for managed IPs. So at the moment, all the configuration I've done at the moment doesn't cost me anything to run. the network manager itself isn't costing me anything. It's not until I then go and actually provision a resource with an IP address, then that's where I start paying for it. So when you provision a virtual machine, a load balancer, something into a subnet that's managed by IPAM, that's where you start paying. And it's, forget off the top of my head, it's about $2. I can't remember. Have a look at the pricing page from there. It seems expensive on the surface of it, but in the scheme of what you're looking at, it's actually not that big of a deal on the way past. And for the lack of headaches, it makes a difference. So if we start here, what I've done is created here 3 top-level pools. So I've got one here for New Zealand North, one for Australia Southeast, and one for Australia East. One thing to note you'll see here at the moment is IPAM's not supported in New Zealand North yet. New region, it's coming slowly. Having said that, we don't actually need, and this is what we'll demonstrate, we don't need the IPAM to be in region to use it in a specific region. So the fact that Network Manager here is deployed to Australia East, within that my pools are deployed across a couple of regions, but then I can use those pools in whichever region I actually want to. The main reason for splitting them and putting them into their own regions really comes down to regional resiliency. If my pool is in Australia East and for some reason Australia East went down, I couldn't allocate IP addresses in New Zealand North because it needs to make a call over to Australia East. Beyond that, there's no real difference from there. So within each of these parent pools, you'll see here I've allocated this out into the different zones, different network zones. So we've created development, hub, production, UAT. And obviously, depending on what you need to do, this is something you can just divide up on the way past from there. We assigned a top level 16, which gives us 65,000 IPs, break that down into some 20s. And if we scroll over, what it will actually start giving us is that utilization. So we can start to understand where are we using the IPs, where might we need some more in future. You can actually get ahead of the curve in regards to that from there. Now, at the moment, our top level says it's 25% allocated. That's not because we've actually given out all of those IPs, but purely because we've assigned them to a pool. And so we obviously can't, once we've assigned one to a pool, we can't assign that from there, so it counts as being used. If I drill, for example, here into the hub IPAM, what we're going to see here is, again, we have a display name, we have a description for that. It's all taggable for costings and everything like that. So all your cost management can be allocated. And then from here, we look over in the allocations. This is the body of where all the work happens. And so as we can see here, we've got 3 allocations, one to a resource, and we have this context here of static ranges. So these are ranges that for some reason may be allocated elsewhere or we're reserving for particular use. We can just mark that as an area that won't be allocated out automatically. And so in this scenario here, I've created just a couple of static ranges reservations just to demonstrate what can happen. So one here I've created based off a quantity of IP addresses, and another one I've created off a couple of prefixes. So again, I'll show you the code that's generated all of this, but we can do it either at these reservations by a number of IPs. So let's say when we're first creating, I want to prevent the first 10 IP addresses from being used. We put that reservation in, that will stop those initial ones from being used as we go past. Or we can say, hey, this prefix from there. And then what we've got here is we've got a virtual network. And so this virtual network, when I provisioned it, I didn't tell it what IP addresses I wanted. All I said is I need a certain number of IP addresses, and it's gone and it's allocated that for me. I can then expand that out, and I can see that I've done the same thing here when it comes to my subnet. So we've got a Bastion subnet. And so we can go here and jump into the Microsoft documentation. Bastion needs at least 30 IPs. Cool, let's drop 30 into that allocation, sort out what we need from there. Firewall needs a certain number. Gateway subnet needs a certain number. So we can just do that based off IP address from there. It goes, it allocates it, and I've not had to think about it. I've not had to divide it up, which from a code perspective isn't so much of a deal, but when you're doing it manually, that's where it makes the difference in terms of that. And so what this looks like, if we jump over to the virtual networks, just to show how we would create a new one. So if I go and I create myself a virtual network, And so we're going to do this one. So we'll create it, and we'll create this one in Australia Southeast. You're not going to be able to see my search from there. I'm sure anyone who's done any provisioning via the portal will be familiar here with, here's my address space. It's going to default to a set of IP addresses. This here is the place where conflicts occur. Because somebody who's not familiar with it just goes barrels on through, they create one with the 10/16 network, and then everything falls apart when they try and pair it into the rest of the network. Usually after they've deployed a whole lot of resources, which therefore makes everything even worse. So what we'll do is we'll get rid of that, and what we'll do here is use this new option here, allocate using IP address pools. So we select that, and we don't need to create a pool. So we can select a pool. And in this scenario here, we're in Australia Southeast production. So I'm going to select that one there, save that. And now I can just go and say, I want to allocate this one a 23 network. I don't have to think about what that is. I don't have to think about it. If I needed to go and add, for example, another one, I could say I'm also going to need a separate 27, maybe from a DMZ pool, for example. So you could have two separate pools and say, right, here's my DMZ that's going to land in here for subnets. Here's my main one. Go and allocate that for me. We'll review and create that one. And this is where you can use Azure Policy to go based on tags, based on location, making sure it's down to the right pool as well. So you can only allocate from the Australia Southeast pool if you've deployed to Australia Southeast. If you've tagged it production, then you can only deploy from the production pool. So those are rules that you can set up. And if we create that, that will go. And because virtual networks are nice and quick to deploy, we're not having to go and jump into our IP address management. We're not having to reserve a range. We're not having to copy it and paste it and get it wrong on the way past. And we're done. So we go to that resource. And as you can see here, we've got a /22 space. Now notice the difference there, because I asked for two ranges from the same pool, didn't I? And now it's given me one that's just gone across the whole lot. And that's fine, because that's available. We didn't create any subnets. So we could have done that at the time. And again, from here, from a subnet, we just take it from that subnet range. So we'll add that, and that'll go work out what IP addresses are needed, or what's available, and it's just grabbed that one for me from there. From here, if I go back to my network manager, go back to my pool, we can have a look at our allocations. And so there's our resource, the /22 and the /24 for our subnet. As simple as that. I didn't even have to think about what was going on from there. In a code perspective, I can then draw that out because it comes back as an output and build my firewall rules from there. That's great for new stuff. But what about all the stuff that already exists? How do we deal with all of that? Well, it's reasonably simple. Again, what we can do is if we jump into a range and an allocation, we can associate an existing resource. So from here, we jump in, and so I'm going to associate this application production virtual network that runs through for a moment. That's one that was pre-created. I had to go through and manually specify what my ranges were. We have a look here at the moment. We had reserved a static range, and now if I refresh that, we'll see it's now consumed that virtual network. So we can take the existing ones, link them to an existing pool, and then continue managing from there. Again, that's now going to stop conflicts on the way past. And as I mentioned, all of this is achievable through code. So here is some bicep that I've generated. So what we do is we're just going through and, again, looping through in this scenario to create those regional level pools, to create the hub pools, reserve some prefixes from there. But if we have a look down here at this app dev virtual network, this gives you an idea of how it all works. So what we're doing here is instead of our address space being defined with specific IP ranges, now we define it with a pool and a number of IP addresses. And it will go and it will give us the smallest subnet range that's required to meet that number of IP addresses. So here, 512, that goes and gives us a /23. Sorry, 500 addresses. From here, our subnets, we do the same thing. We just allocate that out, 64 onto there. And with delegation, application at 120. And I can just go through here and add in an extra number. So in this scenario here, we're adding for an extra 150 IP addresses. We'll let that run in the background for a few minutes. But what that's going to do is go and add a new subnet there. It's going to go and fetch, and it's going to find what IP range, IP subnets can meet that requirement of 150 IP addresses for me. They won't necessarily be contiguous. They won't necessarily be just one. In this scenario, it should go and actually give us 2 subnets associated with the subnet so that it can meet that requirement with the smallest number of IPs on the way past. So we'll let that run through and we can have a look at it once it's done. So that's coming off dev. So if we go in here, we go into dev. So it hasn't updated, but as you can see, we've got our 2 at the moment, and that will come through shortly. Any questions around IPAM, what it does, while we wait for that to run through? Yeah.
When you choose the number of addresses, is that usable addresses or?
No, it's just used for calculating. I haven't actually. No, it's not, because if you put 512, it'll give you just a 23. It won't go, hey, there's 5 that need to be taken out of that on the way past. So that's something to be factored in if you are going, hey, we need a certain number of IPs, that it won't give you that buffer that's required around the subnets.
That made its way to Azure provide?
I don't know, actually. I haven't been playing with Terraform recently, and at the rate at which they're not updating the provider because they're busy in the background, I suspect it probably hasn't made it in yet from there. So, and there we go. We have a live demo fail. Anyway, but that's what we're looking at in terms of that side of things. So. Yeah, so that's, in a nutshell, IPAM and Network Manager. So it's nice to be able to do that. It's been a long time coming, but yeah, thank you very much. And I'll hand over to Matt, and he'll talk about Woodley.